Good morning, my name is Calvin Klein Mange, and I'm going to report my linear programming. For the first problem, the profit maximization, let's read the problem first. A furniture company makes a bookshelf and desk. Each shelf requires 2 hours of carpentry work and 1 hour for painting. Each desk required 3 hours of carpentry and 4 hours for painting. The company has a maximum of 60 hours for carpentry work and 40 hours for painting available each week, and they make a profit of $15 per shelf and $40 per desk. How many shelves and desks should they make? So first I do table, so I know my variables. So for the objective function, set it to mathematical terms to 15x plus 40y. That's your objective function. Then for the first constraints, this is your first constraints. For the carpentry, it's 2x plus 3y less than or equals to 60. For the painting, it will be 1r plus 1x plus 4y less than or equals to 40 hours. This is your you have two constraints. So how do you solve the each point for the how do you solve it for the carpentry? So you just need to change the variable of y into 0. So 3 times 0, it will be equals to 0. Then 2 divided, it will be 2 equals to 60. Then 2 divided by 2 equals to 1. Then 60 divided by 2 equals 30. Then x, it will be equals to 30. Then 3 divided by 3 equals 1. Then y equals to 20. The same as as painting. You just need to change the y into 0. Then x into 0, you will get 40 and 10. Your x will be 40 and y equals to 10. So then how will you graph it? You just need to this is your x, and then this is your y. So for the carpentry is 30 and 20. 30 and 20 for the carpentry. For the painting is 40 and 10. 40 and 10. 40, 10. That's how you graph it, and this will be your feasible solution. And this is your first point, then 30, the 10, and the 0, your non-negativity. And you need to solve this to maximize your profit. So I put again my my objective function. So for the non-negativity, it's 0, 0. So your profit will be 0. I'm sorry. Then you just need to substitute. The first point will be 10 per y. Then 40 times 10, it will be equals to 400. Of course, 15 times 0, it will be 0. So 400. So x 15 times 30 will be equals to 450. Then for the intersection, we will solve this part. 2x, you just need to put your constraints, your two constraints, these two. Then you put your number 2 here, then your number 1 here, then you just multiply it, then the answer will be this. Then 2x plus 3y equals to 60 minus 2x plus 8y equals to 80. You just subtract it, and it will be equals to 5 equals to 20. Then you divide it. 5 divided by 5 equals 1. 20 divided by 5 equals 4. Then your y will be equals to 4. Then you just need to substitute your 4 to the first constraints. Then 2x plus 3 times 4 equals to 60. Then the answer will be 2x plus 12 equals to 60, you just need to transpose your 12 here. So you will get 60 minus 12 equals to 48. Then you just need to divide it. Then your x will be 24. So let's solve it into our objective function. So 15 times 24 plus 40 times 4 will be 360 plus 160 equals to 520. So this is our maximized profit. It is the biggest profit among the 4. So the furniture company should make 24 shelves and 4 desks to maximize a profit of $520. Then let's go to the Excel solver. So how do we solve it? We just need to first change your variable will be x will be equals to carpentry and y equals to painting. Then you need to put your formula here. So your formula will be 15x, this is your x, so it will be 15 times d5 plus 40 times e5. That's your formula here. So for your constraints, it's 2x for the painting plus 3y equals to carpentry and painting. So 2 times d5 plus 3 times e5 then equals less than or equals to 60. It's the same as painting. You just need to put the cell of d5 and e5 here. Just it will be equals 1 times d5 plus 4 times e5. So then how do we to solve it? Go to the data, then press solver. So let's just reset this and I will teach you how to set the objective. First you set the objective. This is your objective, the profit. Then remember we need to maximize it. Then our changing variables will be these two, and this for the constraints, this is this part. You can do this one by one if you like, but I just because it has the same symbol, so I just simplify it. So for our constraints, it will be these two. Then press add. Then our cell reference again will be this 2, and it will be should be integer. Then okay, then you need to solve it. So there are no errors. So okay, so it will be equals to 520. So let's check in our word. Our x it will be equals to 24. This and then 4. Our painting will be equals to 4. Then our profit will be 520. So this is the same as in the Excel solver. So for the next problem will be cost minimization. So let's read the problem. A farmer wants to customize his fertilizer for his current crop. He can buy plant food mix A and plant food mix B. Each cubic yard of food A contains 20 pounds of phosphoric acid, 30 pounds of nitrogen, and 5 pounds of potash. Each cubic yard of food B contains 10 pounds of phosphoric acid, 30 pounds of nitrogen, and 10 pounds of potash. He requires a minimum of 460 pounds of phosphoric acid, 960 pounds of nitrogen, and 220 pounds of potash. If food A could cost 30 per cubic yard and food B costs 35 per cubic yard, how many cubic yards each food should the farmer blend to meet the minimum chemical requirements at minimal cost? So what is the cost? So first I do the table first, so I know my variables. So for the objective function, it's $30 and $35. So set it in mathematical terms, 30x plus 35y, that's your objective function. For the constraints, 20x plus 10y will be equals to 460. I mean greater than or equals to 460. Then 30x plus 30y is greater than or equals to 960. That's your nitrogen. For the potash, it's 5x plus 10y greater than or equals to 220. So we have three constraints. Then how do we solve it? It's the same in the here. It's the same as this. You just need to transpose, change the variable into 0. So you will get 460 over 20 equals to 23. 460 divided by 10 equals to 46. So it's the same as of the three, the phosphoric acid, nitrogen, and the potash. You just need to change the variables of x and y into 0. So for the phosphoric acid, this is your phosphoric acid. It's 23 and 46. For the nitrogen, 32, 32. For the potash, 44 and 22. So this is your feasible area. You need feasible solution area. So you have 1, 2, and non-negativity, and 3 and 4. You need to solve 4. So x equal the non-negativity is 0, 0, 0. So the cost will be 0. So x equals to 0 and y equals to 46. I mean here 46. So 46 times 35 will be equals to $1,610. So, and then for the next is 44 here. 30 times 44 will be equals to 1,320. So let's solve the next intersection of phosphoric acid and nitrogen. We need to solve this part. So it's the same in the maximization profit. You just need to put your 20 here, you put your 30 there, then you just multiply this and you will get this, then subtract, then you will just need to divide 5,400 divided by 300, it will be equals to y equals to 18. Then you just need to substitute the y in these constraints. You just 10 times 18 will be equals to 180. Then you just transpose it. 460 minus 180 will be equals to 280. Then just divide it. Then x will be equals to 14. Then just substitute into our objective function. 30 times 14 plus 35 equals to 18. So 420 plus 630 will be equals to 1050. So we have another intersection, the nitrogen and potash. So it's the same as this. You just need to transpose, put there and put here, then multiply, then divide, then substitute your y into here. Then you will get 600 divided by 30, you will x equals to 20. So then we substitute it in our objective function. 30 times 20 plus 35 times 12, it will be equals to 600 plus 420, it will be equals to 1020. So it has the least of the cost because it is the smallest, 1020 among the 4. So the minimum occurs, it will be 20 and 12. So the farmer should buy 20 cubic yards of plant for the food mix A, and 12 cubic yards of the food for the mix B at the cost of $1,020. So how do we solve it in Excel solver? So we need to put here our formula, and you put our objective function here so you will know. It will be 30 times d5, 30 times d5, then plus 35 plus e5. So that's your formula for the cost. And then for the constraints, it's the same as we do in the profit maximization. You just change your variable x into d5 and e5. It's the same as nitrogen and potash. So how do we solve that in problem solving solver, Excel solver I mean? So let's just clear this first, reset. So set an objective, the cost, then remember we need to minimize it. Our changing variables will be these two. Then for our constraints, this part, then it will be greater than or equals to this part. So you can do it one by one. I just do it for I put it together, so because it has same symbol, so I just simplify it and then add. Then for your integer, just put here integer, then okay, then solve it. So there's no error, so okay. So let's check it if it's the same. X equals to 20, then y equals to 12, then z, then our cost will be $1,020. So it's the same. Then for our transformation model, so the transformation model, the Iker company has 3 plants located through a state with a production capacity of 50, 75 and 25 gallons. That is the supply, 50, 75 and 25. Each day the firm must furnish each 4 retail shops of R1, R2, R3 and R4 with at least 20, 20, 50 and 60 gallons respectively. This is the demand of each retail, 20, 20, 50 and 60. So the transportation costs in hours are given below. So this is the cost, the 3, 5, 7, 6, 2, 5, 8, 2 and 3, 6, 9, 2. That's the cost of transportation going to production to retail 1, so on and so on. Then the economic problem is to distribute the available product to the different retail shops in such a way so the total transportation cost is minimum. So we need to minimize this. So let's solve it into Excel solver. Transportation model I mean. So we need to put our formula here. The formula to know for our total cost is this part. You need the sum of product of this part and this part to this. That's our formula, the sum of product of this part again and this part. So to get our total cost, you need to sum. You can do it one by one. It's 3 times 0. This part, I mean, and this part, you can just do it one by one. But I just to simplify it. Then for our supply, our constraints, so you need or the sum of this part, the sum of this part for our, and this part for our demand, this part, and for the retail number 2, this part are this part for our constraints, and this part. So how do we solve it? Go to the data again and solve. So I just reset this. So select our, set our objective, this part. So remember, we need to minimize it again. Then our changing variables will be this. Then click add. So we need this part, and it should be equals. The symbol here is equal. So need to, our constraint is here. Then click add, and this part, our demand. Then remember, equals. Then this part. Then click add again. Then this part. Then select integer. Then click OK. So we need to solve this. So there's no error. So press OK. You will get this 610 of the total cost of the transportation. Then for the investment portfolio. So let's read the problem. A mutual fund has $2 million available for investment in government bonds, blue chip stocks, speculative stocks, and short-term deposit. The annual expected return and risk factor as follows. So the type of investment is government bonds, blue chip stocks, speculative stocks, and short-term deposit box. The annual expected return is in percent is 14%, 19%, 23%, and 12% in short-term deposit box. The risk factor is 12, 24, 40, and 6. The mutual fund is required to keep at least $200 in short-term deposit and not exceed an average risk factor of 42, and speculative stock must be at least 20% of the total amount invested. How many should mutual fund invest the funds so as to maximize the total annual expected return to formulate linear programming, the LPP. So our solution, so our variable will be x1 will be amount invested in government bonds, x2 will be our amount invested in blue chip stocks, x3 will be amount of invested in speculative stock, x4 will be amount invested in short-term deposit banks. So our objective function, so 14% of x1, so it will be 14 divided by 100 times x1 will be 0.14 x1. It's the same as for the x2, x3, and x4. So when you put it in objective function will be this 0.14 x1 plus 0.19 x2 plus 0.23 x3 plus 0.12 x4. So the maximum amount will be $2 million. Amount available is $2 million. So our first constraints will be x1 plus x2 plus x3 plus x4 plus x5 is less than or equals to $2 million. So our second constraint is short-term deposit should be at least $200,000. So x4 will be equals to greater than or equals to $200,000. I mean, for our third constraints is this average risk factor over decision variables. So when we solve this, it will be equals to this 12x1 plus 24x2 plus 48x3 plus 6x4 will be greater than less than or equals to 42x1 plus 42 times x1 plus x2 plus x3 plus x4 plus x4. Then the answer will be, you just multiply it, then this will be the answer. 42x1 plus 42x2 plus 43, then it has the same x1 and x1, so you just need to transpose it. Then the answer will be 12 minus 42x1 will be 30x1, negative 30x1, plus 24 minus 42x2, it will be minus negative 18x2. Then 48x3 minus 42x3 will be 6x3. Then 6x4 minus 42x4 will be negative 36x4. That's the average risk factor of 42, as said in the problem. The average risk factor of 42. Then our speculative stocks must be at least 20% of the total amount invested. So that's our constraint number 4. This you just need to multiply the 20%, it's 0.2, to our decision variables of x1, x2, x3, and x4. So x3 minus 0.2 x1 minus 0.2 x2 minus 0.2 x3 minus 0.2 x4, then greater than, less than or equals to 0. So when you solve the x3, it will be 0.8 x3. The answer will be here. So this is your fourth constraints. And always do not forget the non-negativity of our decision variables of x1, x2, x3, and x4. So how do we solve it in Excel Solver? So first, you need to put your formula here. So this is our objective function. You just to transpose the x1. The x1 will be government bonds, x2 will be blue chips, speculative stock, x3 short-term deposit banks is x4. That's your you just need to transpose it to x1 will be equals to B10. So 0.14 times B10, then 0.19 times C10, 0.23 times D10, then 0.23 times D10, then 0.12 times E10. That's your formula for to know the profit. So the constraint is x4. You just know the E10. That's our x4. Then it should be greater than or equals to $200,000. Then our constraints is the same. Just substitute it to the right cell, and the same as this and this for our constraints. Then when you solve this, go to the data again, then solve. You just need to clear this. Reset. I'm just gonna reset. So let's look at the problem again. We need to maximize the total annual return. So we need to maximize it. So let's go to the problem. Then this is our objective. So don't forget, we need to maximize it. then our changing variables will be this. Then for our sorry, there's an error. Let's clear this again. Then our objective is here and our objective is here. Then for our constraints, for our first constraint is this, and it should be greater than or equals to this. Then click add. Then to need, because it has this tree has same symbol, I just simplify it, and should be less than or equals to this tree. Then click add. Then for our integer, this part, then click integer, then okay, then you need to solve it. There's no error, so that's how you get the $382,000 of profit. And then let's go for the manpower schedule. So the schedule of the employees. So Bank 24 process checks 7 days a week. The number of workers needed each day to process checks is 17 workers needed on Monday, 13 workers needed on Tuesday, 15 workers are needed on Wednesday, 17 workers are needed on Thursday, and 9 workers are needed on Friday, and 9 workers needed on Saturday, and 12 workers needed on Sunday. All bank employees work 5 consecutive days. So suppose our bank had 22 employees, and their goal was to schedule employees so that they would have maximum number of weekends and day offs. How should the workers be scheduled, I mean? So this is the data that then we're going to solve it in the so first our constraints. So our number needed on Monday, Tuesday, this is the numbers needed on each day. So 17 workers needed on Monday, 20 on Tuesday, 20 then 20 again on I'm sorry, number needed here. So this is the 17 on Monday, 13 on Tuesday, 15 on Wednesday, 17 on Thursday, 9 on Friday, 9 also on Saturday, and 12 on Sunday. Then how do we solve this? So this is R. Put your formula here. So we need to find the how many workers should work on weekend. So you just need to the sum of Saturday and Sunday. Then so how do this our constraints, the formula of our constraints? This is our formula of our constraints, the sum of product of this, the sum of, and for the Tuesday here, and Wednesday, Thursday, Friday, so on, and up to Sunday it's the same, the sum of product of this. Then for our total of numbers of starting is this, the sum of this Monday to Sunday. Then we need to solve it. So let's reset our objective is this, so we need to minimize it. Our changing variables will be this. Then for our constraints, our shell reference is here, then it should be equals to 22. Just put 22, then okay, then press add. Then our constraints is this part, this part. Then it should be less than, greater than or equals to I'm sorry, this is the our constraints needed. So this is the constraints. Then click add. Then for our non-negativities, this, click integer, then okay, then solve. So there's no error. So that's how we solve the manpower schedule of the employees. And that's all. This is the reference that I searched in the web, so I get the problem on the web. So that's all, and thank you and have a nice day.